Hey everyone, welcome to the stream. This is Alfred.
Submarine.
And this is episode 124 of our live streams. We haven't been on the live stream for a little bit. Well, Submarine and Carlos did a live stream last week on Project 14, but we've been on a little hiatus with a bunch of conferences. We went to Maker Faire Bay Area, and a bunch of cool things have been happening. So yeah, we'll get into that later. We'll give a little recap of that later. But for now, this stream is going to be basically showing you how to set up OTA on the ESP32 of the MATRIX Voice so that you can run it by itself, standalone. So without further ado, take it away.
All right, so OTA means like over-the-air programming. So what we're basically doing is setting up like a Wi-Fi interface. I will switch over to my screen. Okay, cool. So we have a Hackster guide that we're going to post. We'll be posting it today, shortly after the live stream, or early tomorrow morning, depending on how exhausted we are after this episode. But yeah, so to start off, I will actually switch to a view where you can see really quick, or actually, I'll just show you right here. So when you start off, you have your MATRIX Voice attached on the Raspberry Pi like normal, and I have a micro SD card with Raspbian Stretch Lite installed, and it can have desktop too. So that's just how we're starting out setup wise. Alright, so I'm going to go right into the guide. It should be pretty quick given that a lot of the sort of pre-processing steps I've already done. And then there's some installation things that you have to do on your personal computer that I may make videos on it later, because those are more like, okay, installing the ESP tool chain, things like that. That doesn't really make sense to do in the live stream. Okay, so getting started, the Raspberry Pi setup. So this is like the typical setup we do when we have a Raspberry Pi. We'll do like curl, you know, and echo to get the matrix repository and key. And I've already done this. I'm just doing it again to sort of show you. I won't update and upgrade because I mean, I've already done it. It won't take long, but you know, just in case. So you just like paste it into your terminal. I'll copy paste at this point, and then you copy Matrix Creator in it, and that's the package that initializes, like, you know, okay, this is a Matrix Voice or a Matrix Creator. In this case, obviously Matrix Voice. So you need those packages to initialize the FPGA and everything. And then you have to reboot. Don't forget that. So I'm going to start with Voice ESP32 Enable. So also, this is on the Pi's terminal. I SSH'd into the Pi right before the stream. So here we have Voice ESP32 Enable. What this does is, this touchpad is not always friendly. Okay. Also, my hands are sweaty. But okay, so Voice ESP32 Enable. This just enables the ESP32 interface. There's this ESP tool thing in Python. It enables that. We're actually going to use the ESP Pi tool, esptool.py. So what this command does right here is it resets the ESP32 flash memory. So if there was any program installed on it, it will erase it. And this command won't run unless you enable voice underscore ESP32 underscore enable. So, you know, that's why you have to run that program. And then, so yeah, so it successfully reset the, you know, the memory. That's great. Reboot the Pi. So, doing that. Cool. So, personal computer setup. So this can be a little bit annoying, but depending on what you know, machine you have. I did it on Windows yesterday. It does work, Windows users. I will remove this. You know, I tested it just to make sure it's functioning, but it's just a little bit slightly more annoying. Linux and Mac, pretty standard setup. So install Git. That's pretty simple. Just, you know, go to the Git website. It'll walk you through downloading. Simple to download. So you need Git. And then for the Mac, so the ESP toolchain, oh no, I forgot to open in a new tab. Anyway, this is for Mac OS because I'm on a Mac. It's also pretty much copy-paste, so you just follow their instructions, and you should read what they're saying as well, just so you know what you're doing. but for the most part, it's copy pasting. The important things that I wanted to mention here is once you install, you get their tar files, you extract them, but then you do have to set this like path variable. And what this does is it makes sure that when you're using, like when you're flashing the ESP32 from your personal computer, it'll flash it onto the Raspberry Pi, but it has to know where to look for the ESP toolchain. And so that's why this path variable has to be made sort of global in your terminal. And it tells you how to do that. So for example here, you need to update your path variable in like home directory.profile. So I'll like show you right here, .profile, and so this is where I put mine. So I just copy pasted the export path, like this is the ESP, the extensa thing is the tool chain, and then the IDF path it comes next. So like that's the main thing you need to do for the tool chain. And then when you're setting up the IDF, which is kind of, I'm thinking of it as the IDE kind of, it's like the development environment, or if I click on it, it'll probably tell me exactly what IDF stands for. But yeah, so this will, development framework. So yeah, this will tell you how the steps to program or to set that up on your computer as well. And so that is also pretty straightforward. You literally just clone into their repository, and then you have to add the IDF path to your profile again. So that's why I have this line. So yeah, so that's for Windows. Going down for Mac, you have to just put this line in there. This line in here, and that's what I had done before. And then just make sure that like the changes went through by doing, so if I do Control X, I didn't actually change anything, but if I do print env IDF path in my terminal, it will show me the path, so I know it worked. So just ensure that that's working, because if that part doesn't work, the rest of it won't work either. Okay, so then installing the Arduino IDE on your PC. So what we're doing here is we're using the Arduino IDE as a development environment, and it's just like their ESP30, like Espressif itself provides resources to like nicely have like, they have lots of libraries for it. They have like you can set ESP32 boards as your board, so it's just a nice environment to do it in. Maybe later we'll come up with examples on how to program it over the air with like a simple text editor program, but for now Arduino IDE is a nice way to go about it. So you first install the Arduino IDE, you just go to their website. It's pretty straightforward, Windows, Mac, Linux. I already have it installed, so I'm not going to go for that part, but then I'll show you the setup of the IDE once you have it. So Arduino, okay. I was a little bit afraid it was gonna pop out like things with our password and Wi-Fi on it for a second, because I was like, oh my god. Okay, so so once you have the Arduino, here okay, I'm just gonna make it a little bit bigger so you can see. I'm not actually gonna write anything, it's all settings. So you go to File, Preferences. So you go to File. Oh, funny. It's actually not File Preferences for Mac, it's Arduino Preferences. I will edit that in my guide. But then you basically copy paste this URL right here into the additional boards manager URLs field, and then click OK. Once you do that, you go to Tools, Board, then you go to the boards manager, and then in this filter your search place, whoa, okay. Okay, there we go. Yeah. Yeah, ESP32, and then enter, and then this will show up. And I don't know if people, can I even zoom into this? Probably not, but well, I can just make
it's
it
visible.
Okay, as long as it's visible. But basically,
It'd
this
be hard
is
on a phone, but
right. Yeah. So basically, like this one thing will pop up. There's only one thing, and you just have to install it. So there's gonna be. I already have it installed, so it's not showing up. But on the right, there's gonna be this little drop down, install, and like just click the latest version, and then click install.
what's on the left?
Well. Okay, yeah, it's on the left on the Mac. I did it on Windows yesterday.
Mac is just
like,
special, that's all.
Mac is special, yes. In good ways and bad ways.
Yes.
Mostly good ways.
Yeah.
I must admit.
Yes.
Anyway, impartial. So then you close, and that's about it. So that's setting up to make sure you have the ESP32 board show up. So what's gonna happen is, sneak peek, you go to Tools, Board, and a bunch of ESP32 boards will show up, and as I'll show you later, we are using the ESP32 dev module. But okay, moving on the tutorial. So flash the first program with over-the-air code. Exciting. Okay, so clone the following repo with matrix HAL code for the ESP32. Okay, so I'm gonna go, so this is my computer's terminal. This is not on the Raspberry Pi. Here, to make it not confusing, I'll go to this tab. Clear, I'll go to the home directory. Actually, I won't go to the home directory. I will open this in a folder I have called GitHub Clones. Actually, Mac does not have that option. I'm just gonna go in there. CD desktop, and GitHub Clones. Okay. So this is where I want to do my stuff. Okay, so I'm going to clone the matrix HAL repository. Matrix HAL ESP32. This is HAL exported over for ESP32. And I already have Git, so it clones. That's nice. Once you have the Arduino IDE on your computer, which we do, there will be a folder called Arduino. So for me, that folder is, if I go to Documents, I have an Arduino folder right here. So if I go into Arduino, there's a Libraries folder. And so what this part is telling you to do is to copy the matrix HAL folder you just cloned into the matrix libraries folder. So if I like cd into what I just cloned, matrix, what is it, underscore HAL underscore, oh, ESP32. Ah! I just cloned it. Maybe I cloned it in a
Matrix
different...
IO HAL?
Oh, yes, this is true. Oh yeah, I see it. Okay, matrix IO HAL. Okay.
Teamwork.
Nice. So if you go in there, what you want to put in the Arduino libraries folder is, so you go to CD components, and then you see this HAL folder right here. This is what you want to copy. So if I go into HAL, you'll see it's kind of like a library. It has a bunch of CPP, like C++, like HAL source files. So this is what you want to copy. Let me go back up. So you can copy it like, like a normal person, or not a normal person. You can copy it like a non-terminal person, wow. through the UI, or there are also terminal commands to do it. So if you do cp-r, and then this you would have to do this particular command from outside of the HAL ESP32 directory, but if you were, since we're inside here, we would do it. We would just do cp-r and then HAL and then documents, Arduino, libraries. But I'm not going to do that because, as you saw, we already have that in my libraries folder. But okay, so then the next part. I'm going to cd back into my GitHub clones directory and clone this. So this is the Matrix Voice OTA code. So there's a bunch of stuff in here that will help you with OTA. Cloning, great. So then you copy that folder, well, one of the folders inside that folder, ESP32. So you copy the Matrix Voice OTA folder into the Arduino libraries folder as well, because that's like a library which is, I can show you, library, which, like, for example, if I go into here, .cpp, you know, there's a bunch of stuff in here to get OTA set up. Good thing is you never have to worry about it. It's in a library. So you just copy that folder into Arduino into Arduino libraries, and here I have that right here. So you can copy it using your file manager, you can copy it using this command line command as well. Okay, so moving on. We are going to, so we've already CD'd into ESP32 Arduino OTA, so now I'm going to go into starter. And that's where we start. So, you know, there's also a command line to open it in Arduino, or you can just go to Arduino and open it, but I'll just open it in Arduino or through the command line so I can show you it works. I was really happy when I found this because I've always tried to open things through the terminal and like didn't know that you can just do open the file name. Yeah.
I didn't know that.
Isn't that cool?
That's so useful.
Yeah.
Oh my God.
It's nifty.
That could have saved me so much time.
So, yeah, it's
the
pretty
directory.
nice. Yeah. Okay, so I can't zoom in here. Maybe I can here. Tools, file. Maybe, how do I zoom in? Oh, Command plus isn't working.
Typically there's a view, but...
True. Zoom. Okay, well, we don't really need to worry too much about the contents of the file.
On the top right of the window.
That's the serial monitor. Yeah. Or, well, okay. The code we don't need to worry too much about. I can kind of talk about it so you know what it's doing roughly, like overview. So it's importing Matrix Voice OTA. So that's what's the functions that are, you know, setting up the Wi-Fi connection and all that stuff. And then it's importing a bunch of Matrix HAL, you know, header files, which we just copied into the Arduino libraries folder. That's why they're able to, you know, be recognized by Arduino. So I have rate 16,000 here, assuming if you use the mics, but this program doesn't use the mic. It's just kind of to show you how you would set it up if you were using the mics. And I also have like the Wishbone bus, Everloop. This is just a simple turning the Everloop blue example, the starter example. So this is initializing those objects. This is initializing the OTA objects. You have to put in your Wi-Fi SSID, your Wi-Fi password. And then you can choose like an ESP32 ID and an ESP32 password. All that does is the first time you upload, it'll ask you for a password for authentication, and then you just put whatever password you had entered here. And then the setup, so in setup we have like initialization of the Wishbone bus, which is something we do for our general examples as well. And then setting up the Everloop on that bus, and setting up the mics on the bus, even though the mics really aren't doing anything in this program. And then microphone core, and then setting up OTA, the OTA object that we made. And then in loop, you're looping the OTA object, because like it basically checks every loop iteration if there's, you know, a program being uploaded. And then right here we just have all the LEDs being set to blue, and then that being written to the Everloop. So simple program just to start out with. So what we have done to abstract away our password from you, Alfred had this great idea. So I am going to copy this .h file with our password on it, and Wi-Fi credentials, so you don't get to peek at that.
It's a secret.
It's a secret. Okay, so open a new tab.
It's not password.
Desktop. Nope, it's not password, because if it was, Alfred would like go crazy.
I would.
So we go into the starter. So I'm gonna copy paste. You don't have to do this part. You can just straight up put your Wi-Fi credentials in there. But this is a nifty thing to know for if you are doing live streams / showing other people who you don't want to know your password. Yeah. So we're just going to pound include, and then the Wi-Fi creds.h, and it was called Wi-Fi SSID, and oh, it doesn't have to be in quotation marks because we just defined them in there. and then it was Wi-Fi PW, right?
Mm-hmm.
Wi-Fi PW. Okay, perfect. So I'm gonna save that. I'm gonna put this away. Okay, so that was a detour. Going back to the guide, in the Arduino IDE, go to the Tools tab in the menu bar. Okay, so clicking on Arduino IDE, Tools, and then select ESP32 Dev module. I already did that, but basically, you from this huge list, you have to fish out ESP32 Dev module and select it. And then you have to set the flash size, which is right here, to 4 megabytes, right there, and upload speed to 115200. So that's right there, and that's 115200. So we actually tried this with the higher upload speed, and the upload speed works, but we were trying to, but if you want to say, for example, connect like a USB TTL, or what is the FTDI, basically, yeah, like FTDI. Some, yeah, both are the same. If you connect something to get like a USB serial, like say error logs or something like that, you wouldn't be able to do it if it was faster than 115200, because it's too fast for it at that point, and you can't see the error logs. So just an FYI, because I ran into that and was very confused.
Let us know if you want a guide on how to do that.
Yes, so that's actually a good guide to set up. It's simple if you have the device. I don't think it's that expensive. The FTDI is probably maybe like $5,
$10
yeah.
on SparkFun.
Yeah, but it's nifty. So yeah, you just like connect a couple pins, and then you can see in your terminal, you know, anything you serial.print in here, you'll be able to see. But you actually over Wi-Fi can't use the serial monitor, unfortunately. So all right, so we set all of that, change the SSID and password. Oh, I guess I went there before already, but anyway, so you know, you would just do that here, as we did, and then go to Sketch and then export compiled binary. So Sketch, export compiled binary. I don't know if you can see, but it says compiling Sketch. I really hope it works, because if it doesn't, I don't really know what to do. It should work, theoretically. There's always doubt during live streams, because, you know, sometimes luck isn't on your side. So it takes a little bit, but basically at the end of it, it should say done compiling. And then I guess I can start talking about what I would do next. So when you do Sketch and then export compiled binary, what happens is it creates this file. So our file is called starter.ino with a capital S, and it creates like a binary file called starter.ino.esp32.bin. So here, I go here, and you can see there's a starter.ino.esp32.bin. And this is the file we will flash through our Raspberry Pi to the Matrix Voice. This is only one time, because now after that, you can do it over the air, over Wi-Fi. Mm-hmm. So the reason I say move the file to starter from starter is because sometimes, and I don't know why it only does it sometimes, I think sometimes Arduino forgets, but then it realizes. But generally, when you open an Arduino like .ini file, it'll ask you to create a folder that file would go in. So most likely, if instead of doing it from the terminal, I had double clicked on this to open it in Arduino IDE, it would have asked me if to create a folder that this file would be within. So then this file, starter.ino, would be inside a folder here called S starter. And so I would have to and the bin file would be created inside that folder, and I'd have to take that bin file out into this directory, because deploy ota.sh and starter.ino.esp32.bin have to be in the same folder, because deploy ota.sh is flashing that file, unless you change deploy ota.sh to go into a directory, but I'm not. So if that's an issue for you, check that deploy and the bin file for starter are in the same directory. So I'm going to open, for the next steps, I'm going to open deploy _ota.sh in Visual Studio Code. all you have to do here is change this IP address to the IP address of your Pi. So I'm going to do 241 for my case right now. And then all of this stuff, it's basically, you know, using the baud rate, using the serial port to flash, and basically, I don't know if you can even see anything here. So all I changed was this IP address right here. So it's kind of, what this is kind of doing is it's SSHing into the Pi and then piping this command into the Pi. And the reason you're doing it from your computer is because your PC is what has all of those heavy-duty ESP, like, tool chain and you know, development framework and everything. So I'm gonna save this, close it, and so this all seems good. They're all in the same directory. I'm now gonna go to my terminal. So I am also in that directory. I'm gonna clear it for you all. Okay, so now all I have to do, you can also edit it with Nano. So I have just directions for that. Nano's just like the text editor inside the terminal. You would just do this. But yeah, I already edited it in VS Code since that's also nice. Okay, so we're just gonna do sh deploy ota.sh and it'll ask for the password. Great. I put in my Raspberry Pi's password. You should see the ESP2 .py wrapper. This is all good stuff. This means it's working.
Hooray.
Hooray. So this one takes a little bit longer. Well, not that long. It takes like, I think about a minute. I actually never timed it. But yeah, so watch how it flashes, and when it restarts, the LED ring should be blue. So I will actually hold this up right here, though it's only 25%, probably a bit early to hold it up. But, so as you saw in the Arduino program, it's blue, so the LEDs will turn, when they turn blue, you can just do other stuff and wait till they turn blue, and you know it's worked. But yeah, so basically we're actually done, but I'm gonna, like, you know, obviously wait to show you guys everything and then show you how to select the port and everything. But this is you know, pretty simple, and it only took so long because I talk so much. It actually would have been much faster if
I think it took as long as it took me.
Okay, well,
yeah.
Okay, that's good.
I had to read everything.
True.
Talking
I mean, that's
is
the
faster
thing.
than reading.
Like yesterday, Boris was doing it, and
Sometimes.
he was just copy pasting things without reading, and it was a lot faster. But if you do that, there are actually things here where you have to read, because there are things with moving like moving files to different folders, and if you just copy paste commands without reading for this one, you might get some errors. So you might want to be 98%. Okay.
You guys are lucky. When I tried this, it was much more basic than this guy.
Oh, haha, yes.
And it still worked first try. So.
Yeah. So that's a positive thing. Oh, yay, they turned blue. So this is a good sign. So now that it has turned blue, the ESP32 is flashed, because this was an ESP32 program. If you don't believe it, let me show you right now. I am going to unplug.
You didn't turn it off properly.
Remove from the Raspberry Pi and plug in directly, where's the port? Oh, directly to this Matrix Voice. If I can do this, okay. And then, well, give it a second and it should turn blue. Yay! Oh, it worked, yay! Nice. High five. Okay, so standalone. So now, the extra fun part is I don't have to put it back on the Raspberry Pi to change the color, or, you know, do other things for that matter. So what we do next is I'm going to go to your Arduino IDE, and I'm actually going to close it. So you restart the Arduino IDE. I'll quit it from here. Okay, so go back to Arduino. And so once Arduino opens up, this should show up as a network port, which I didn't know was a thing in Arduino before looking into this stuff, which is pretty cool. So if I go to Tools, actually, I'm going to open my starter.ini file again, because that was nicer. Okay. So what I'm going to do to show you that this actually works is I'm gonna add, so right now all the LEDs are being turned blue because LED.blue is 5. Now I'm gonna make LED.red 5 as well. So red and blue make purple.
In case you didn't know.
So I will save that. Command S. Don't do that if you're Windows because you don't have a command button.
Control.
Control. So when I go to Tools, if I go to Port, what's happening is I have a Matrix Voice at a new IP, and it is, oh, what happened? Oh, Tools. Okay. Ooh, again. ESP32 dev module. Okay, so this is actually this device right here. So all I'm gonna do, all I did was change this, the LEDs to have red and blue equal amounts, so it should be purple. You know, maybe I'll make it just red because it might be easier to see on the live stream.
And I like red, so.
And Alfred likes red, so you know, there's always that. So we're gonna upload using this button. It's gonna compile and upload together. So right now it says compiling sketch right here if you can't read it. Compiling sketch, and then once it compiles the sketch, you can also, like, it'll most likely have a little loading bar here so you can see the, like, how long it's gonna take. And then it's going to start, it should prompt me for, so remember how we set your chosen ESP32 ID to Matrix Voice and then your chosen ESP32 password to voice? It's gonna ask me for a password after it compiles, which usually doesn't take this long, and after the first time it's, like, you know, even quicker. But yeah, it'll be quicker for the most part. I think maybe it's being confused by this, but hopefully not. Okay, so once it compiles, what should happen is it'll ask me for my password. I'll say voice because here, I can show you. So password, so I type in voice because that's the password I set, and you do
it if you
upload.
Want. That way you have two hands.
Okay, and so it says authenticating okay, and then uploading. So this is a bit ugly, but, like, yeah, there's basically these little dots that keep being made. But once it's done uploading, it will say done uploading, and you'll be able to see your standalone ESP32 Matrix Voice turn to LEDs, turn to red, which is, you know, any minute now. It's still uploading. Done uploading. Okay, so it does take a bit to upload, and
there.
Yeah, but look, once it's done uploading, it changes pretty fast. Yeah, so this is fun because only the first time ever you need to, you know, put it on a Raspberry Pi, go through this process, but after that, it's just simple Arduino IDE stuff. And then also, soon, we're going to, well, we actually have a bunch of, on, like, a branch that we haven't pushed to master yet, we have a bunch of examples for Rainbow and, you know, just like some other, there's mic energy, things like that, that you can do using Arduino IDE. For these examples. The reason it's not pushed to master yet is because all of the examples, like, don't fully work yet, but we're working on that. So this is it. I'm just gonna give you a couple quick, like, pointers. So the OTA object.loop actually is a little slow. It slows down the loop because, you know, I think it checks a lot of things, which takes, like, about, like, almost a second, which is not ideal. Obviously you don't want that to, like, for example, here we're just setting the LEDs to a color, but if you want rainbow happening, we were like, oh, but, like, that won't do, right? So what you could do, which was an idea, like, Boris had, is, like, put OTA object.loop in, like, you check it every 10 minutes or something like that. Like, you put it in you have a timer. Like in Arduino you can get timer libraries left and right. There might even be a default one, I don't remember. But you can just put a timer and maybe check it every 10 minutes, which might be a little annoying. When you upload, you have to, you know, wait. But
or you could even kind of make, like, a jumper, like detect a jumper. So use the GPIOs on the front or back of the voice and just detect if two of them are, like, power to one of the pins is
like a button
connected.
Or something.
Essentially.
So, like, every time you want to upload, you, like, you know, you have some sort of, like, input, like a button or a jumper or something. So, and that's when you check for, like, the OTA object.loop part, so that it doesn't slow down the.
Or maybe you reboot it.
Yeah, or what you can. Yeah, or what you can also do is put, say, things that are doing continuously updating things. You can put them in a while loop with a conditional, or So what we did for Rainbow was we just put it in a for loop. So yeah, you can do different things like that to work around that. And if you absolutely hate it, then just flash it through your Pi. And for that, like, you can...
Depends on the use case.
Depends on the use case, exactly. And what's nice is, with this package, even if you're not doing OTA, you can always use the deployota.sh file to upload any sort of binary file you make with Arduino IDE. So it's also just an easier way to keep on uploading, like flashing through the Pi. So you can just like build off of that. But yeah, so I'm gonna switch back to our front camera.
Okay.
And let's see, go here, and
I'm gonna go get something.
Okay.
Give me like 5 seconds.
Okay, I'm giving Alfred 5 seconds to go get something while I switch to a version of the front camera that doesn't have a banner. Okay, cool. So that was ESP32 OTA.
Almost 5 seconds. Okay.
Yeah, I hope you enjoy that, and Alfred will show you something cool.
Yeah, so that was awesome example. It was really easy. I'm excited to see what people are going to make with it. And so a couple weeks ago, we were at Maker Faire Bay Area, and it was really fun there. We'll talk about it more in a sec. But while we were there, we went to the Hackster office. We met with Alex, and we met this new person, Jay. He's Odd Jay on Twitter.
Yeah.
He basically made this like cool spider
companion
bot.
Yeah.
Awesome! It's so cool.
Cool.
And while we were at their office, we made a little project which basically uses the ESP32 OTA guide so that you can flash a matrix voice, which right here, and we made a watch. So you can see here there's like 2 batteries stacked here, so it's total 4,000 milliamp hours of battery. And if I plug it in,
oh, you have it powered. Nice.
Yeah, it should have battery, probably, maybe. Yeah, cool.
Very nice.
Okay, so now the cover goes over. It has like zip ties as the wristwatch because I didn't have too much time to design a strap. So zip ties worked, and I carried around a zip tie cutter just in case, maybe a battery shorts or something. I don't know. Better safe than sorry. So yeah, so that's the watch. And then basically what we had this doing is it can connect to a Wi-Fi network. So it was like my phone's hotspot. And we go to the IP of the Matrix Voice on it, and then it opens up a local web page. And it had some buttons so we could make it do like a rainbow effect. We could make it do the mic energy demo. So it's basically pulsing the LEDs to the whatever volume of whatever sound is nearby. And yeah, it was really fun.
Yeah,
so just a little tiny example.
Like, it's simple, but people loved it. Like, it was just it's also fun to walk around with.
Yeah, it is fun. I was I saw Adam Savage's Sunday sermon, and it was raining, and so I had to like hide it in my hoodie while watching it. But when I got a book signed by him, and when he saw it, he thought it was really cool. So that was fun.
That's awesome. Yeah. Awesome.
But yeah, so Maker Faire Bay Area. I guess we can go into a little bit of that recap. It was amazing. We were there for almost a week in San Francisco, like 6 days. Met with Hackster, went to a bunch of after parties, did a lot of networking.
Yeah.
It was very tiring. I slept a long time when we got back.
Yeah. It was tiring, but it was also like a different experience because personally, I hadn't ever networked in a chill environment. Like,
and it's all developers and engineers and techie people.
Exactly.
So it's fun.
It's fun.
We can talk
like
about
learn
fun things
while, enjoying some snacks and beverages.
It's not like going to like a bar or a club or something. It was nice.
It was very nice. Yeah.
It was. So we did that. Went to a bunch of things, met some cool people. One company that we met and we spoke to for so long.
Oh, they're amazing.
She already knows. They're a company called Haddington Dynamics.
Yes.
And basically they have made this robot arm that is controlled via an FPGA
Well, like this is what it was doing. Like really.
Like it was very fluid. And
so fluid.
We spoke to the CEO of it for maybe like an hour, and he was just explaining every little detail of it. One of the most notable things is like typically why you can't like have robot arms near people, like you know those big ones that have like make cars, is because they like can't, they're not sensitive to touch. It'll go through you. And the ones that are sensitive to touch then aren't precise. Because then they have to have like some wiggle room or something to be able to tell the touch. And so they came up with a way that uses light essentially as the encoder. Yeah, but light encoders.
Optical encoders.
Yeah. And it's so precise. They sample it so often that it, like if you touch the robot, oh my god, how did Snips heard me? Hey Snips. Hey Snips. Turn on the light.
I don't know why I thought you said turn off the light.
I don't know either.
That's odd. Anyway.
It's very odd. Okay, continuing. So it like if you touch it, it is so precise and samples so frequently that it knows that you are touching it before you know you're touching it. Like your nerves are slower than the robot, which is
yeah.
Oh my god.
It's crazy. So I was reading up on it yesterday again, actually, just because I wanted to remember what he had said. And so generally optical encoders, it's like a bunch of slits, right? And then you can see at what rate the light is going. Mm-hmm. So what they do is they use a bunch of math. So they have like fine slits in their optical encoder in the first place, but then they use a bunch of math to within each slit have about like several more, like they use some analog property of light to like within each slit have even more granularity. That's why they can do it like so precisely.
Wow, that's amazing. Yeah,
like, and their whole thing is based in math.
Yeah, like, it's all math. Yeah, it's all math. Like they made
they were saying like when somebody touches it, right, it knows what the air, like by how much it's off from its like like desired,
the robot was doing a specific motion, and when when the reset position is kind of like a tree, it goes back and stands like this, and so you could hold it and you could like stuff that like click the motor. So a normal robot, it would be way out of place. You'd have to completely recalibrate it or reset it yourself. But when it goes back to its position, it went back exactly to what it was at before. Yeah, it is such a beautiful, and the whole thing is open source. Mm-hmm. It's amazing. It's like, check them out. They won the Hackaday prize last year. It was so cool talking to them. We're working on some things with them. We'll talk about that later at some point.
As it develops.
Yes. But yeah, they're amazing. For sure, check them out. Mm-hmm. So other news, guess contest. Yes. So our Snips Hackster contest, we're currently wrapping up the final details of it.
Yes, we're aiming for June 17th.
Yes, June 17th?
Yeah, it's a Monday.
Or the week of June 17th.
Well, I think June 17th is the Monday, but it's the Monday of June
17th is the Monday.
Okay, then that's when we want to launch it.
We'll try.
We'll try. It's the aim, but it will be launched this month.
Yes. So yeah, that's the contest. Be sure to check it out once it comes out. What else? We had the Project 14 live stream last week. You want to talk about that? You were on it.
Yeah. So Alfred couldn't be there, but
I was in Canada.
Yeah. So that was cool. But Carlos and I were here. We were actually right here, and we had the robot arm here, and we basically showed it was a robotics based live stream, and so a bunch of community members showed off their robotics projects. There were some really cool ones, like somebody who had made like a pretty like precise drone, all custom, very cool. And then just a lot of like just fun makery projects, like somebody's like, oh, I want to make like a little cup holder that moves around or something like that. I don't know, like just fun little projects, and we got to see like little videos of those. And then we showed off our own, like we had like the Snips controlled like Pixar version, and then also showed off the GUI. So we had like an open source kinematics library. If you just Google open source kinematics JS library, like it's
basically
one of the
first one on GitHub.
Yeah, exactly. And basically you just use the GUI to control it. And at Maker Faire, we had people trying to pick up like these little we had an Asian night market theme, so we had people, we were in like the 96 boards booth, so they had these little cute like I guess like what do you call these baskets?
Yeah, like
yeah.
It's kind of like that Chinese takeout.
Yeah,
box.
Chinese takeout box. Yeah. So we had people sort of try to hook it on and pick it up, and that was the challenge. And
yeah.
I think people had fun with it.
Yeah, kids have fun with it.
Yeah.
And adults.
And
right?
adults. Yeah, I had fun with it too. Yeah,
right.
it's pretty fun because it moves with your mouse, like you know. And next version should be joystick control. That would be really cool.
Joysticks.
Yeah,
that'd be cool. We'll make the 3D print it or something. I don't know. We'll figure it out.
Well, it'll be
something.
cool.
So and then next one, right now, Project 14 or Element 14?
Element 14. Yeah,
Element 14 is hosting a road test with the Matrix Voice. So I think we're still in the application period where you can submit to receive like free hardware and review it, which Samreen is pulling up the webpage.
So you can see it. They can see this camera and then this screen.
Okay, cool.
Yeah.
So this is the webpage. So check it out. It's I can't say that.
So enrollment closes in 10 days and 19 hours.
Okay, we'll include the link in the description of the video once the video finishes.
Yes.
Because that's a long link.
Yes. Oh. Yes.
Oh my.
Long link.
But yeah, this is basically the page. Cool.
Yeah. And then this was the Project 14 page. If you want to check out the live stream, you can. Oh, that's not.
Oh my god,
that
image! they love messing with us and putting like
really funny
the silliest images, and they put a caption. My mind blown here. Wow. I'm pretty sure that's when they were like showing us in R2D2 that the what's his Sean and Connor made. Yeah. And it's mind blowing too. Yeah. It was.
So it was mind blowing. This was just a moment of mind blowingness. An unflattering picture captured. But yeah, so you can check out the live stream here. It was a fun one. You can just have it in the background. Check out some fun projects people made. And the road test. So I guess I'll come back here and we can close up.
Well, there's one more announcement.
Oh, yes. Oh.
I'm happy to say, you guys have never met this person, but this is a person, he's one of my best friends, like actually one of my best friends since high school. He's been with us on and off because he goes to school, like university, since, it's been like 4 years now. But I'd like to introduce you all to Boris. Boris, come over here.
Come on, Boris. All right, here. So
here.
there. So this is Boris.
Yeah,
he has been tirelessly working on Matrix kernel modules and NFC for you all. We will be talking about that later when it's about to come out.
He
but
is
just
amazing.
Know the face behind
trying to get NFC working
some
now.
of the work.
Yeah. So he's going to get NFC like read working so that everybody can read NFC tags, and then any other NFC features that you guys want, let us know and we'll add them because the library that NXP provides is it's a lot. Like
it's a lot of functions, but it's kind of hard for the user to use easily. So I'm just trying to wrap them in like a .read function. So you just do NFC sensor, you make your object, and you do .read, and then Carlos, who's the
he's doing it in
Matrix Lite, he's gonna port it upwards into Lite.
Yeah, that would be very
so
cool.
One layer at a time. But yeah, this is Boris. You'll be seeing a lot more of him this summer.
Yeah.
And cool.
Awesome. All right. So
great. Well, let's all say bye.
Bye. Yeah. Okay. All right. Thank you for joining us.
Thanks.
And
Thank you.
I guess see you next week.
Yeah. Bye.
Bye.